Hey everybody, we're live and in studio. So today we'll be trying to finish off the 2024 set for chapter number 4. Please understand that the way I've taught chapter number 4 is that I've included periodicity and period 3 in this particular chapter, just like I've taught it. Periodicity and period 3, it has group 2, it has group 17, and it also has nitrogen and sulfur. So periodicity, period 3, group 2, group 17, nitrogen and sulfur, all of these chapters are combined in my MCQs just like they were combined when I was teaching them, because they all make sense after you study them all together, right? So without further ado, I'm going to start off solving these questions. Please understand that your periodic table should be by your side at all times. This chapter especially, and moles even, they need you to have the periodic table by your side. Without the periodic table, you are limbless, you are helpless, limbless, and you've already fractured your bones and legs if you don't have the periodic table. And if you remember the periodic table by heart, that's something else, but nobody requires you to remember it as far as O-level, IGCSE, and even A-level is concerned, right? And even in university, I don't think you'll be required to rote learn periodic tables, But yes, we will be tested on our concepts. Now, these questions used to be tested back in the day. 1, 2, 3 mean A, 1 and 2 mean B, C means 2 and 3, D means 1 only. Such MCQs you will see, if they are to ever appear on your screen, you'll see it and you'll answer it on these bases, right? Without further ado, let's just start solving questions. Let me also increase the brightness. Let's go. Demolishing questions. So, question number 1 says, in this question, and please understand that this chapter is so important that around 60 MCQs alone have been tested in 2024 from these chapters, right? For me, it's just a single chapter, which I call chapter 4, but it has period 3, group 2, group 17, nitrogen. So 4 chapters constitute almost 60 MCQs for 2024. That's how important these chapters were. Okay. Now, in this question, Q is used to represent a halogen atom, right? Halogens are obviously group 17s, right? So Q is halogen atom. Magnesium and calcium each form a compound with chlorine and a compound with bromine. One of these compounds contain the element in group 2 with the higher first ionization energy and the element in group 17 with the higher QQ bond energy, right? With the higher bond energy. What is the formula for this compound? Now, please understand, between magnesium and calcium, we have to select which one has the higher first ionization energy. Think about it. The periodic table should be by your side. I know it, but I'm going to still add the periodic table because obviously you guys don't know the periodic table by heart. We also don't know it by heart, but we've done a lot of practice. Now, calcium is down the group. If you compare it to magnesium, calcium will have a lower first ionization energy. Why would calcium have a lower first ionization energy? Because obviously down the group, the nuclear charge increases, but the shielding also increases, right? And therefore, the effective nuclear charge becomes constant. But since the atomic radii increases, the distance from the outermost electron and the nucleus increases. Therefore, the net nuclear attraction decreases for the outermost electron, and therefore, it has a lower ionization energy. It is easier to be removed, right? So between magnesium and calcium, which fella would be the element with the higher first ionization energy? That would be magnesium, and therefore, C and D are automatically incorrect. And in group 17, which one has a higher bond energy? Does chlorine have a higher bond energy, or does bromine have a higher bond energy? Right? Chlorine or bromine. Now, we all know that the higher bond energy, why would chlorine have a higher bond energy compared to bromine? Chlorine has a higher bond energy effectively. Why does it have a higher bond energy? Because it's smaller. Number one, it's smaller, and the bond length is therefore shorter, right? It's smaller, and therefore the bond length is shorter, right? It has a shorter bond. Br bond is longer. It's longer because the Br atom is large. It's large. The overlap region is less, right? So it's a longer bond, right? Less area of overlap, longer bond. And for chlorine, the bond, it's smaller in size compared to bromine, and therefore the bond length is shorter, and therefore this covalent bond becomes stronger. This sigma bond is stronger compared to Br sigma bond, right? So we know that that chlorine has the higher has the higher bond energy, and therefore B is wrong and A is the correct option. That's how easy these MCQs are. Compound X contains two elements, X and Y. Element Y is in period 2 of the periodic table. Period 2 of the periodic table. So element Y is amongst these fellas. Good stuff. And he's saying element Y, the p subshell, in one atom of element Y, the p subshell has all three orbitals occupied. So if you have the p subshell, you know p subshell has 3 orbitals, and it's saying all the orbitals are occupied. So all would be occupied. Tuck, all would be occupied. But he's saying only one of these 3 orbitals is fully occupied. One of these 3 is fully occupied. So all are occupied, but one is fully occupied. So which element are we talking about? It's P4. It's in period 2 and it is P4. Which fella is P4? Period 2, P4. So this is period 2. This is P1, P2, P3, P4. So you're effectively talking about what? You're talking about oxygen. Oxygen right here. Oh, oxygen. So this fella is oxygen, right? And therefore, if I just look at the options, B and A are wrong because oxygen should be there, right? That's element Y. Element Z is in period 3 of the periodic table. In one atom of Z, the p subshell has only 2 orbitals occupied. So in one atom of Z, it only has 2 orbitals occupied. So you have 1 and 2. That's it. The third is empty. He's not talked anything about the third orbital. He's saying just 2 orbitals are occupied. Occupied means there's an electron. He's not saying they're fully occupied. He's just saying they're occupied. See, just like he stated here, they're occupied. So when he wrote they're occupied, I just drew 1 electron, 1 electron, 1 electron in my electron inbox diagram. But when he said 1 is fully occupied, then I drew the second electron right here, right? So here he's saying that only the p subshell has only 2 orbitals occupied. The third is even empty. So period 3 is right here, and it should be P2. Period 3 and P2. That's why the periodic table approach was so important. That's the reason why I'm me. So period 3 is this fella right here, and it's P2. P1, P2. So that fella is silicon right here. So it's what? Silicon oxide. That's the compound that you have. So SiO2. Done. That's how easy these MCQs are. That's our next question. The graph shows trends in 4 physical properties of elements in period 3 excluding argon. Which graph has the electronegativity on the axis? That's why I've made sure that I make you guys see all the graphs in the live class. I've made you guys visualize all the graphs, and I've made you guys even draw it on your own hands, all the graphs that you guys are seeing right here. Which graph is this? Look at this. Sodium, magnesium, and then aluminum, and then there's a huge jump in for silicon. So what is this? This is actually the melting point. This is actually the melting point graph, in which you know that between sodium, magnesium, and aluminum has the higher melting point between these 3 because aluminum contributes more electron to the delocalized electrons, and therefore it has a stronger electrostatic force of attraction, stronger metallic bond, right? And when you look at silicon is a giant molecular lattice, a giant molecular structure, so the highest melting point, right? And then it dips right here, down here. Why? P4 is phosphorus right here. And then why is sulfur more than phosphorus? Because sulfur has more a number of electrons, so greater ID interaction. So you know this is melting point. You should know. If you don't, conceptual misunderstanding, go watch the recording later, go revise your notes. What is this? It's just as you go from sodium to chlorine, it's just going down. Let's go down. Apple bottom jeans, down. What is this fella? This fella. You should be able to know this, you know. This is atomic radii. I have made you guys seen it. Atomic radii. You know that across the group what happens? Across the period what happens? Across period 3 the atomic radii decreases because there's an increase in nuclear charge. The shielding almost remains constant, And you know why I'm writing almost constant. The shielding remains almost constant. The effective nuclear charge therefore increases, and therefore the atomic radii decreases. The pull on the outermost electron increases, right? So the atomic radii decreases. The pull on the outermost electron increases, therefore the net nuclear attraction increases, and therefore the atomic size decreases. So this is atomic radii. And what does he want? He wants electronegativity. And electronegativity, mind you, follows the same trend. Follows the same trend. The reasons are same. The reasons are same for electronegativity, which are for ionization energy. It does not necessarily have exceptions. There are no exceptions in electronegativity. If you look at this graph right here, this is the graph of ionization energy. The first ionization energy from sodium to magnesium increases and then dips here. Why? Because of additional shielding in magnesium. Increases right here and dips between phosphorus and sulfur. Why? You should know this now. Because of spin pair repulsion and then increase. So this is ionization energy. So C is also incorrect. And then D was the most appropriate answer, because you know electronegativity increases. The reason is the same, but the graphs aren't same. There are a lot of exceptions in ionization energy, in the first ionization energy of period 3 and period 2. Electronegativity just increases across the period. Why? Because increase in nuclear charge, shielding almost remains constant, and the effective nuclear charge increases. Therefore, the pull on the outermost electron increases. That's the reason. The reason is similar. Right? Next. What is the acid-base nature of SO2? Now, SO2 is an acidic oxide. It's an acidic oxide. Therefore, C and D are wrong. And SO2, it is not. See, it's all a psychological game even. Those students who rush in solving questions, especially when it comes to MCQs, they are going to get cooked. Because it's not SiO2, you dumbo jumbo. It's not SiO2, it's just SO2. SO2 is a gas. It's a gas. It's a simple molecular structure. A is wrong. This is how they confuse you. They know that this is all a game of nerves. Read it slowly. There's a lot of time. Next. Element X and Y are in period 3 of the periodic table. Element X is either phosphorus or sulfur. Okay, it's either phosphorus or sulfur. I know phosphorus and sulfur exist like P4 and acid. And he's saying element Y. So this is X. X is either this or that. And now he's saying that element Y is either sodium or magnesium. Okay. Now let's see what he's given me. He's saying element X, okay? Element X forms an oxide that reacts with water to give a solution containing the aqueous anion XO42-. Now, even if I don't know the reaction, let's suppose you could not recall a reaction, right? Let's suppose you could not recall a reaction. XO42-. Does the sulfur when it bonds with oxygen, right? There's the sulfate ion. Does the sulfate ion have a 2- charge, or does the phosphate ion have a 2- charge? Even if you did not know the equations, you have to be very quick. Phosphate is 3-. It's never 2-, sir. It's SO4 which is 2-. So automatically, B and A are absolutely wrong. And then it's saying 1 mole of element Y reacts with 1 mole of chlorine molecules. At the end of the reaction, all of element Y and all of the chlorine molecules have been used up. Let's see, if it's sodium reacts with chlorine, gives you NaCl, right? And magnesium reacts with chlorine to give you what? MgCl2. Why MgCl2? Magnesium has a 2+ charge, Cl is 1-. For 1 magnesium ion, you need 2 chloride ions. Now look at this beauty. If you balance out this equation, you have 1 chlorine on the right, and you have 2 chlorines on the left. So I have to half this. What should I multiply 2 with to get 1? X is equal to 1/2. So this in fact is not the correct answer. Sodium cannot be the correct answer. Why is sodium not the correct answer? Because for 1 mole of sodium, half a mole of chlorine is required, sir. For 1 mole of sodium, half a mole of chlorine is required. And he's saying for 1 mole of this element Y, 1 mole of chlorine is required. Not half, 1 mole. And yes, for 1 mole of magnesium, in fact, 1 mole of chlorine is absolutely required. So these are very basic, no rocket science whatsoever. So for 1 mole of chlorine, 1 mole of magnesium is required. Therefore, D is the correct answer. Now, what do we mean by this part right here? Even if you did not know, you solved it. But what do we mean by this part? See, he's saying X forms an oxide. So when phosphorus forms an oxide, it's P4O10. And when sulfur forms an oxide, it's SO2 or SO3, right? So he's saying, be it SO2 or be it SO3, it doesn't really matter. But he's saying that when it forms an oxide, then this oxide reacts with water. Come on, tell me this. You should have also written it down slowly and gradually as you were solving this. When it reacts with water, what happens? When P4O10 reacts with water, what happens? It forms phosphoric acid, H3PO4. That's what it forms. And we know why it forms this, because of the maximum oxidation number. This is +5 here. It should be +5 here, right here. Oxygen is pretty electronegative. I've given you all the reasons for it, all. I think I'm the only one who gives these reasons. And if out of these, SO3 were to react with water, SO3's negative ion is what? SO3's negative ion is SO4 2-, and SO2's negative ion is SO3 2-. And we know why that's the case, right? Again, electronegativity. So it will form H2SO4 if it is the SO3. So even if he wanted me to identify which sulfur oxide you have, that would have been the SO3 oxide. This is what I mean when I say concepts are very important. So that's it. So I've given you even the equation. See, in this case, phosphate is PO4 3-, not PO4 2-. That's it. Q is a semiconductor. Now, if you did not know, silicon is actually a semiconductor. Si is actually a semiconductor, right? But he's saying that the chloride of Q reacts with water to form white fumes and an acidic solution. It forms white fumes and acidic solution, which period 3 is element Q. So the chloride of Q, magnesium chloride, then you have aluminum chloride, Al2Cl6, then you have SiCl4, and then you have PCl5. Now, by just looking even at semiconductor, you would have gone for silicon. But again, I want you guys to recall your equations through these MCQs. It's very important to. My job is not just to give you the correct answer. If you want the correct answer, C is the correct answer. But that's not how it goes. The teacher's job is to teach you and revise the concepts through the MCQs. So what do? He's saying it gives you an acidic solution, absolutely acidic solution. So what happens when you add MgCl2 to water? When you add MgCl2 to water, what happens? Sir, number one, MgCl2 does not react with water. It just dissolves in water. It just dissolves in water. Gives you Mg2 plus ion and the chloride 1 minus ion, right? So 2 chloride ions right here. And obviously it is slightly acidic. It's about pH 6.5 because the magnesium ion is smaller, has a concentrated charge on it. It'll attract some hydrogen ions, and that's what's going to make it pH 6.5. But such a beautiful concept. Does magnesium chloride react? No. It dissolves. Conceptual clarity. That's why I say, sir. That's why I say. So magnesium can't be right? Now, what aluminum does is, what does it do? Aluminum chloride, when you add it to water, what happens? We know, and I've actually taught you the entire mechanism of how it works. When you add aluminum chloride to water, it breaks into aluminum 3 plus ion, the chloride 1 minus ion. This aluminum 3 plus ion pulls 6H towards itself because again, it's smaller, has a higher concentration of, has a higher charge density, it's smaller. So it is basically aluminum H2O whole 6 and has a 3 plus. This 3 plus ion attracts these bonds with these 6 polar waters, right? But what ends up happening is that this charge is so dense and so concentrated that it pulls a hydrogen ion out of it. So this is what happens. It's Al, H2O, 5, OH, and it has a charge of 2 plus. Why? Because a hydrogen ion has been pulled out. So absolutely, this will give you an acidic solution. But sir, aluminum is not a semiconductor. Even if you did not know this, aluminum is a conductor. Have you ever heard that aluminum is a semiconductor? Have you ever heard that aluminum is a semiconductor, or sodium is a semiconductor, or magnesium is a conductor? They are metals, they are conductors, not semiconductors, they are conductors. So B is wrong, not because it does not give you white fumes or an acidic solution. It absolutely does that, and it also reacts, sir. These are both correct, but it's not a semiconductor. And on the other hand, if you have silicon, phosphorus would react, PCl5 would react. It would absolutely give you phosphoric acid, and it would give you HCl. But again, PCl5 is not a semiconductor, or phosphorus is not a semiconductor. Not PCl5, phosphorus, Q. He's talking about the element. So phosphorus is not a semiconductor, therefore, or not even a conductor because it's a non-metal. So D is also wrong, and the only option you're left with silicon. And you know that when you take SiCl4 and you add it to water, what does it give me, sir? It gives me SiO2 plus HCl. Right? So it absolutely gives you white fumes and an acidic gas. White fumes, acidic gas because of HCl. HCl की वजह से white fumes are produced. Hydrogen chloride is produced, and acidic solution is also because of HCl, because some of the HCl dissolves to give you an acidic solution. And I've taught all of this. And fun fact, this is also an off-white precipitate. So an off-white solid also ends up forming. Right? So he's not written that. And also silicon is in fact a semiconductor. So all fulfills all the options. 7. V and W are two compounds. Each one contains a different group 2 element. Okay, V and W, two compounds. Each one contains a different group 2 element. A sample of each of the solid is added to water, shaken, and the pH of the resulting solution is measured. Okay, V is giving you a pH of 13.6, and W, so V should be alkaline, right? So when you add it to water, it should also be soluble and should also be alkaline, right? Now, if you look at W should be soluble in water, because see, when you shake it with water, this is what happened. The resulting solution. So if you shake it with water, it gives you solution. That means they are soluble. W and V both are soluble in water, and this is alkaline, strongly alkaline in fact, not weakly, strongly alkaline, and this one is a little weakly alkaline. Right? So let's check it. Based on this, I can directly eliminate A and B out. Why? Because barium sulfate and magnesium sulfate, fun fact, is insoluble. So वो तो गया ही गया काम से. That's gone. That's out of the option. No question whatsoever. Magnesium sulfate, on the other hand, will dissolve in water. Absolutely it will. But the problem is, will it give you an alkaline solution? There is no hydroxide ion in magnesium sulfate. It's a sulfate ion. So no hydroxide, right? So B is also wrong. Between C and D, which one is V? V is the more alkaline one. And we know that what happens to the solubility of hydroxide down group 2? What happens to the solubility of hydroxide down group 2? It becomes more soluble or less soluble? So it becomes more soluble. So it becomes more soluble. Which should be V? Should it be barium or should it be magnesium? V is more soluble. That's why it's more alkaline. V is more alkaline because it is more soluble, or vice versa, or vice versa. So if V is 13.6, it should definitely be what? It should definitely be barium hydroxide. And magnesium hydroxide is weakly alkaline because it's not as soluble in water. Is it? We know this. It just checked out a simple solubility rule that you were supposed to know. And the reason for that, you study in A2. In O level, in AS level, we just know down the group the solubility of hydroxide is increasing and sulfates decreases. And we've seen it through practical examples. Aisha, I would refrain from making such remarks, right? Okay, all, I don't want to use these all term, but normally, yes, Aisha, you are correct. But don't make these shortcuts. If the syllabus does not require you to know something, there's no need to know it. Okay. Achha. Compound L decomposes on heating. 1 mole of the products is gas M. M reacts with unburned hydrocarbons to form peroxyacetyl nitrate, PAN. What could be the formula of N? What a beautiful question, sir. How is PAN? How is PAN formed? And I think that then you guys will say, sir, you are praising yourself, but I've taught you how PAN forms even though it was not a part of your course. I said that when you have nitrogen oxides, when you have NOxes, nitrogen oxide, right, it is a pollutant in itself because it results in an acid rain. It results in acid rain, right? So it's a pollutant itself, but it also results in a secondary pollutant called PAN, which further results in photochemical smog. Have I not taught you this? So NOx indirectly causes smog, not directly. NOx causes PAN, which causes photochemical smog. And how is PAN formed? I've also taught you this. Volatile organic compounds react with, which are normally unburned hydrocarbons, react with nitrogen oxide to give you PAN. This is what I've taught you guys in the class. If you don't remember it, go over and see the class of nitrogen and sulfur. So we're seeing compound L decomposes on heating. One of the products is gas M. Now it can't be carbonate because we know that PAN is formed through nitrogen oxide, right? So it can't be carbonate. It must be between A and B, because when calcium nitrate, and it is so simple. Like I don't even have to look at all of this explanation for it, because the formula of calcium nitrate is calcium is 2 plus NO3 is 1 minus. The formula is CaNO3 twice. But please, you should know everything, right? And now let me prove it to you. What has actually happened. This is how MCQs should be taught. Calcium nitrate is there, thermally decomposed, formed what? Calcium oxide plus nitrogen dioxide plus half O2. This is how you balance it, and I've taught you guys balancing. This nitrogen dioxide would further react with what? It would react with volatile organic compounds. What would it cause? So it would cause photochemical smog. Right? It was called it would cause PAN, which would cause photochemical smog. PAN mixes and combines with some other compounds in the air like ozone. PAN mixes and combines with ozone and some other species in the air and forms photochemical smog. And this nitrogen oxide reacting with volatile organic compounds is synthesized by sunlight. Right? That's why you would see it a lot in Delhi, you'd see it a lot in Lahore, because sunlight hits that place a lot more often. And nitrogen oxides are present because of all these factories and whatnot, releasing NOxes and these internal combustion engines. And did you need to know all of this knowledge for solving this MCQ? Absolutely not. You just needed to know that PAN is caused by nitrogen oxide. So C and D are wrong, and between these two, the formula of B is correct. Literally. Isn't it easy? Isn't A levels easy? Hanji. Our professor used to say, bole, guys. Are you all like dead or alive, enjoying or not? I hope you guys are enjoying as much as I am enjoying this. Teri yaadein. Guys, speak for yourselves. Yes. Yes. Clear. Okay, great. It's like clear. Let's go. In reaction 1, concentrated sulfuric acid is added to potassium chloride. Potassium chloride, add conc H2SO4. We've seen such reactions. What happens? Sir, K plus and HSO4 minus would form KHSO4 plus HCl would form. And notice how this concentrated sulfuric acid was not able to oxidize the chloride ion in potassium chloride. See, it has the same oxidation number before and after, -1 and -1. Similarly, you could also have said that this chloride was not able to oxidize this sulfur in concentrated sulfuric acid. It's +6 and +6. Remember all of this good stuff. Now he's saying that this is what happens. Fumes are produced. They are produced because of HCl being formed, you dumbo, and they are bubbled. So these fumes are produced and they are bubbled into an aqueous potassium iodide solution. So you have HCl fumes being produced, and these HCl fumes are bubbled where? These HCl fumes are bubbled in a potassium iodide solution. So you have potassium iodide and HCl is also bubbled. So this will also become aqueous, right? Because hydrogen chloride, if it's a gas and you add it to water, it becomes hydrochloric acid. So you have these negative ions, right? There's no precipitate that's going to form. Nothing is going to form. It's going to be a colorless solution. Why? Because potassium chloride is also soluble. All group 1s are soluble. Potassium iodide is also soluble. Hydrogen iodide is also soluble, or hydroiodic acid in this case you would call it. Hydrogen and chloride is also soluble. Hydrochloric acid in this case you will call it. So all of this is soluble. Nothing, no transition metal ion, no precipitate forming. It's just a colorless solution that's going to form. So observation 1 is not a brown solution, you dumbo jumbo. It's a colorless solution, right? Do you know why he's saying brown solution? He wants students to get confused with the idea of chlorine being added to potassium iodide, in which case chlorine would displace, because it's the more reactive halogen, right? So the more reactive halogen displaces the less reactive halogen from its salt solution, forming KCl and I2 aqueous, and this I2 aqueous is brown. So students with weak concepts would have gone for brown because they must have remembered or recalled something like this, but that's not the case, is it? It's not chlorine being bubbled, it's HCl being bubbled. In reaction 2, potassium chloride is dissolved in aqueous ammonia. Okay, potassium chloride is right here. Okay, K plus and Cl minus. It is dissolved in aqueous ammonia. Aqueous ammonia is basically ammonium hydroxide. That's aqueous ammonia, right? Because what happens is, I've also taught you this, ammonia gas added to water gives you aqueous ammonia. You could write it like this, NH3 aqueous, or you could have written it like this, because it's a base, it's a proton acceptor, it'll accept a hydrogen ion, and what's going to form is NH4 plus, OH minus, they're going to co-combine together, form NH4OH. Done. So you have ammonium ion and hydroxide ion right here. So what's going to form? Ammonium chloride, soluble. All ammonium salts are soluble in water. All group 1 salts are soluble in water. So soluble, just a colorless. That's it. C is the correct answer. No white precipitate, nothing. There's no precipitate being forming. There's no transition metal ion. Kidhar se colors bane? Where should the precipitates form? They're all soluble. Done. Next. The table refers to hydrogen halides, which is correct. Hydrogen halides means HCl, HBr, HI, HF, whatever. Now, okay, and if I talk about hydrogen halides, I have also taught you how hydrogen halides work. So it's HBr. What am I doing for myself? I'm just exaggerating the fact that as you go down the group, the halogen atom becomes larger and larger, and therefore, because it becomes larger, there is less overlap, and what happens? The bond length increases, and therefore the bond energy decreases. You need less energy to break this HI bond, and that's why it constantly, I'm also connecting it with the reaction of conc sulfuric acid. That's why it constantly can reduce concentrated sulfuric acid over and over again to SO2, to here S to H2S, because this bond is easily broken. This is what I'm doing. I'm exaggerating it for myself. So I know this, I remember this, just like I've been taught. So he's saying easier to, easier to oxidize down the group. Sir, easier to oxidize down the group. Is it easier to oxidize down the group? Absolutely, absolutely. It's easier to oxidize H2SO4 down the group, right? You could see it. You could see it's easier to oxidize. This statement is absolutely correct, because you know that HI can easily oxidize sulfuric acid to SO2 to S to H2S. So reduce sulfuric acid. Right? So it will itself get oxidized. It will reduce sulfuric acid to H2S to S to SO2. It will reduce sulfuric acid, conc sulfuric acid, but this conc sulfuric acid can easily therefore oxidize HI, right? If this can reduce conc sulfuric acid easily, conc sulfuric acid that also means that conc sulfuric acid can oxidize this easily, right? That's why it can go into it goes into I2 and whatever, right? And HCl, conc sulfuric acid does not even oxidize HCl. It does not oxidize HCl. No, it doesn't, right? The reaction stops after the first part. So this is absolutely a correct statement. He's saying thermal stability increases down the group. Absolutely not. Thermal stability decreases down the group. Thermal stability has to do with how easily you can break this bond. You can easily break this bond, right? So stability actually decreases. Thermal stability has to do with, thermal stability has to do with, if you can easily break this bond, it's not thermally stable, right? If you can easily break it, it's not thermally stable. So if I'm saying thermal stability increases down the group, that would mean I wouldn't be able to break this bond, but I can break this bond. So thermal stability decreases. And if stability decreases, then therefore reactivity increases. Remember, stability, reactivity are inverse relation. So if something is less stable, it will be the most reactive, and that's what you see in HI's case, right? So thermal stability increases? No, it decreases. That's why you can break the bond easily. That's why you can break HI far easily. And you know why it happens. The same reason. Less overlap, bond length increases, bond energy decreases, and therefore thermal stability decreases. Thak karke ye toot jata hai, right? So this A is incorrect based on the second option. More difficult to oxidize down the group. No. It's easier to get oxidized, right? Conc sulfuric acid can easily oxidize this, or you could have also said this can easily reduce conc sulfuric acid. So both are correct statements. They are just vice versa. It's just two sides of an apple. You can say either or. Increase, this is wrong. So B is wrong. I don't even have to read this. Easier to oxidize down the group. Yes, in fact, it is easier to oxidize down the group. And the thermal stability decreases down the group. Absolutely it does. That's why HI's bond can break easily and therefore undergo reaction. So C is the absolute correct answer. It's not more difficult to oxidize. It's easier to oxidize, right? It's easier to get these hydrogen halides oxidized down the group. And conc sulfuric acid does that. You see conc sulfuric acid doing that shit. Done. Next. Rapid fire is going on. Rapid fire. 3 statements about ammonia molecules and ammonium ions are given. In aqueous solution, ammonia molecules, aqueous solution of ammonia is what? NH3 reacts with H2O, forms what? Ammonium hydroxide. It forms the ammonium ion and the hydroxide ion, because what happens? Ammonia is actually a weak base. It is an acceptor of proton. So when it accepts the proton, it leaves behind a hydroxide ion. So ammonium ion and hydroxide ion combined together, you could even write it together like NH4 OH. Thuk and tuk. Right. I think in aqueous ammonia solution, the ammonia molecules form a coordinate covalent bond with the hydroxide. Yes, should I absolutely tick it, right? Please give me a go ahead. Give me a go ahead. Come on, give me a go ahead. Yes, give me a go ahead. Oh no, you dumbo jumbo. The ammonia molecule, ammonia is NH3, ammonium is NH4. The ammonia molecule forms a coordinate covalent bond with the hydrogen ion right here, with this hydrogen ion, not with the hydroxide ion. It's ionically bonded with the hydroxide ion, not a coordinate covalently bonded. So sir, A is absolutely incorrect, or 1 is absolutely incorrect. Ammonium ions are Bronsted-Lowry acids, and that's true. And you learned this in chapter 9 as well. If you studied O levels from me, I've also taught this, that ammonia, and even in nitrogen and sulfur I've taught this, that ammonium ions are slightly acidic. They are slightly acidic. That's why they react with strong bases. Right? Their salts react with strong bases. So this is correct. The NH bond angle is larger in the ammonium ion than in the ammonia molecule. If you look at the ammonia molecule, what's the bond length? Shabash. Or the bond angle, my bad. This is ammonia molecule and this is the ammonium ion. H, tuck, 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 tuck. Shabash. The ammonium ion is a tetrahedral shape, 109.5. And this is trigonal pyramidal. So if it were trigonal pyramidal, if this lone pair was not here, it would be 109.5. Now it's squeezed in a little more, it's 107. Done? So what is he saying now? He's saying the NH bond angle is larger in the ammonium ion than in the ammonia molecule. Yes, in ammonia molecule it's 107 and in the ammonium ion it's 109.5. So it is absolutely larger. So 2, 3 correct option C, done and dusted. Next. अब पता चल रहा है. Now do you guys actually, enjoy this? Now do you guys actually know why I stress so much on concepts? MCQs, I swear, are a piece of cake if your concepts are clear. I'm doing these MCQs for the first time with you guys. I've never done them before. Never, ever, ever. I'm doing it for the first time with you all. Khair. Again, a reaction between two gases takes place on the surface of a catalytic converter on a petrol engine. So we know catalytic converter already, I know it can be NOx, reacts with carbon monoxide, gives you nitrogen and gives you carbon dioxide, right? And you have rhodium or platinum as your catalyst, right? Now, you understand that if you look at, it's saying in this reaction, 4 reactant molecules produce 3 product molecules. I just read that. 4 reactant molecules produce 3 product molecules. What could be the 2 reactant gases? So reactant gases, first of all, let's eliminate A out and let's eliminate B out, because carbon dioxide is a product gas and it's not a reactant gas. Now it can be C, it can also be D, because nitrogen monoxide is also there and nitrogen dioxide is there, and that's why I've always written NOx here. NOx means it can be nitrogen monoxide or nitrogen dioxide, because otherwise the entire purpose of the catalytic converter would diminish. It would finish. If it were to allow nitrogen monoxide to go away or nitrogen dioxide to go away, it would finish, right? But what do you need to understand? Out of these, and this is also carbon monoxide and carbon monoxide, out of these, which one should be the correct option? Well, 4 reactant molecules should give you 3 product molecules. Let's write the balanced equation. NO plus carbon monoxide gives me what? N2 plus CO2. Similarly, if I have NO2 plus carbon monoxide, what would it give me? It would give me N2 plus carbon dioxide. We need to balance it out. So you have how many nitrogen? 1 here and 2 here. I'm going to put a half here, and you have 2 oxygens on the left, 2 on the right, and you have 1 nitrogen on the left, 1 on the right now, and 1 carbon here and 1 carbon here. Now if you multiply this with 2 just to remove the fraction, if I multiply this entire equation with 2 just to remove the fraction, you'll get a 2 here, a 2 here, and a 2 here, right? 1 over 2 multiplied by 2 is 1, right? Now 4 reactant molecules are giving you what? 1 plus 2, 3. So 4 gives me 3 in this case. In this case, what's happening? You have NO2, carbon monoxide, and you have nitrogen and carbon dioxide. So you have 2 nitrogens on the left and you have 1 nitrogen on the right. So I'm going to put a half here, and you have one thing more. Oh, you have 2. Let's balance it properly now. Wait, I'm just going to put a 2 here to balance it properly. So you have 2 times 2. You have what's it called? 2 nitrogens on the left and 2 on the right. 4 plus 1. 4 plus 1 is right. अच्छा, ये balance हो सकता है कि नहीं? 4, 1, 2. If I put a 2 here, then I'll have to put. You can balance this through what's it called? You can balance this through redox maybe. Let's check it out. Wait. So, my dears, I've balanced it through redox. There's an increase in oxidation number from there's a decrease in oxidation number from +4 to 0. So I've written decrease by 4, and I've saying, hey, +2 say you went to +4, so increase in oxidation number by 2, and so you need to make these two equal to each other. So multiply this by 1, multiply this by 2, a 2 and 2 drops here, a 1 and 1 drops here. So this is the balanced equation. Now here what's happening is 3, 1, 2, 3. This is 3. 3 is giving me 1, 2, 3. So in this case, 3 gives me 3, not 4 gives me 3. Never compromise on your concepts. Never. Learn to ask why, please. So D is wrong. C is the correct option. with nitrogen monoxide. And you could have stopped here. In the exam, you could have stopped here. But my job is to also teach you how to balance this stuff out. It's through redox that I've balanced it through the oxidation numbers. Which oxide is insoluble in aqueous sodium hydroxide? Again, a lot of you would go for B, but B is incorrect. Why? Why? Because B is insoluble in water. It's not insoluble in sodium hydroxide. Don't make hasty decisions. Aluminum oxide would react with sodium hydroxide. It's an amphoteric oxide, reacts with sodium hydroxide, some water to gives you sodium aluminum tetrahydroxyaluminate. Right? So Na, Al, O4, O4, right? This sodium is a 1 plus ion. You don't need to know the name of this, to be very frank with you. So OH minus, OH whole 4 minus, this is the aluminate ion, right here. AlOH OH whole 4 minus, right? That's why the formula is NaAlOH4. And you could balance it later on. I don't care. I've already balanced it and learned and taught you guys how to balance it. Now, P4O10, SO2, they all would react with sodium hydroxide because they're both acidic oxides. Acidic oxides do in fact react with bases, right? P4O10, and I've even shown you these equations, react with sodium hydroxide. What would it give you? P4O10's negative ion is PO4 3 minus. And sodium negative ion is sodium 1 plus. So what would this form? This would form Na3PO4 plus H2O, sir. And what would form here? What would form for SO2? SO2 plus NaOH. SO2's negative ion is SO3, the sulfite ion right here, or sulfate 4 ion, right? And this is the sodium ion right here. So when you combine sodium ion and sulfite ion, the formula should be Na2SO3, right? Sodium was 1 plus, SO3 was 2 minus, cross multiply, you get Na2SO3 plus H2O. That's what's going to form. So these two will in fact react. You don't need to write reactions. I am just recalling your entire chapter through these reactions. If you ever at any point you feel like you don't remember the reaction, go over it again. MgO is actually the correct answer. It's insoluble in aqueous sodium hydroxide because see, MgO is a basic oxide. NaOH is also alkaline. It's also base, right? So base does not react with base. Bases react with acids, not bases, right? So A is incorrect. A is actually the correct option. It's the one that's insoluble. Next question. Sodium and sulfur are burned separately in oxygen, okay? Each reaction, so sodium and sulfur are burned separately in oxygen. Directly, what should click in your brain? What should click in your brain? Click in your brain, click in your brain. Sulfur burns in a gas jar of oxygen, with a gentle blue flame. Sodium burns with oxygen with a brilliant or bright yellow flame. So, Na plus O2, yellow flame. This was like so basic, such a basic question. And SO2 is a blue flame. Yellow flame, blue flame. Done. Next. 15. Shabash. Shabash, shabash, shabash. Sir, shouldn't we have half and 2 above for nitrogen to be balanced? Where? Which question are you talking about? I'm talking about this question right here. I'm talking about this question. I already balanced it with half, but I wanted whole number, so I multiplied it, this entire thing, with 2. Come on. I hope you've gotten this, right? NO plus carbon monoxide gives me N2 plus carbon dioxide. This is 1 N on the left, 2 on the right. Put a half here, multiply this entire equation by 2 to remove this half. So 2NO plus 2CO gives me N2 plus 2CO2 because 2 multiplied by 0.5 is 1. And that's 4 giving you 3, what the requirement of the question was. Next. Read it, yaar. Read it. I'm tired. Read it. Shabash. Read it. Hi Noori, tu bach ke dil laga, na teri, na meri. Okay, last question because I am tired. I wanted to do 60 MCQs, but I'm going to do 15 today, 15 tomorrow, 15 day after, 15 day after. Not tomorrow. Tomorrow we have a proper class, but I mean like whenever we sit, we're going to do 15, 15, 15. And this is what should trigger the moment of truth, which is this chapter is hell of important. Can you guys see the number of questions tested from this chapter? Can you guys see just in 2024 you have 60 questions tested, the maximum number of questions tested from any chapter. Although this is not one chapter, these are 4 or 5 chapters that I have combined, but I've just taught them in one chapter because they might make much more sense in that one chapter. Okay, so X and Y are elements of period 3 of the periodic table. Again, periodic table should be my best friend in this particular chapter, in every chapter effectively, but this period 3. So this is it's this right here, period 3. Tuck, 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 tuck. Okay. So he's saying what? He's saying what? What basket? What is he saying? Also, let me just fix this. I want this to fix. Pix. And this was fix. I'm just, what am I saying? Okay. So he's saying Y has a greater atomic number than X. Okay. Y and X. Oh, makhi maar di maine. Y and X are both in period 3. And Y has a greater atomic number than X. Note that, right? So whatever Y is, it has more number of protons. Peace. Right? The stable ion formed by Y has a greater radius than the stable ion formed by X. Okay? Which means if Y were to form, see, Y can also be a positive ion and Y can also be a negative ion. Please do not mistake this. Y cannot be sodium. That's for sure. Y can't be sodium. Why can't Y be sodium? Because Y needs to have a greater atomic number than X, and both are in period 3. So Y can be magnesium and X can be sodium. Y can be aluminum, X can be magnesium. Y can be silicon, X can be aluminum, magnesium, sodium. If Y is aluminum, then X can be magnesium and sodium. If Y is phosphorus, then X can be silicon, can be aluminum, can be magnesium, can be sodium. Right? Pretty logical. Now, logical. The stable ion formed by Y has 18 electrons. Okay, that's so important. What does this tell you? This tells you that if sodium were to form a stable ion, sodium forms a stable ion of 1+, doesn't it? Magnesium forms a stable ion of 2+, right? They are all metals. They tend to lose electrons, 3+. Now, when sodium loses an electron, it moves to 10. It moves to the electronic configuration of neon. When magnesium loses 2 electrons, moves to the electronic configuration of neon. When aluminum loses 3 electrons, moves to the electronic configuration of neon, right? It has 10 electrons now. So Y can never, ever be sodium, magnesium, or aluminum. So sodium was right off the bat. It was incorrect. Y couldn't be that, because then what would X be? And then all these 3 are wrong. So Y is right here in this column, right? And he's saying when it forms an ion, it has 18 electrons, right? So it can't be argon, because argon is a noble gas. So Y is either silicon, phosphorus, sulfur, or chlorine. That's the idea. Because we know that, and even in silicon, phosphorus, sulfur, and chlorine, you could eliminate silicon, because sometimes silicon tends to lose 4 electrons, sometimes silicon tends to, gain 4 electrons, and normally silicon, normally speaking, it just undergoes covalent bonding, normally speaking. So you could have done that, but okay. So I'm just left with phosphorus, sulfur, and chlorine for my thought process, right? This is how my thought process is working right now. Achha. Now I think Y has a greater radius than the stable ion formed by X. So what does that mean? If Y forms a negative ion, like phosphorus 3-, right? This will have 18 electrons. Sulfur 2- has 18 electrons. Chlorine 1- has 18 electrons. All these 3 have 18 electrons. It has the electronic configuration of argon right here. And so if I am saying that Y must have a greater radius than the stable ion of X, which means X is smaller, X must be smaller. Okay. Now I think which row is correct? The number of electrons in the stable ion of X, are they 18 or are they 10? They can't be 18 because Y is 18. If Y is 18, X can't be 18. Why? Because if Y is phosphorus, X needs to be either sulfur, aluminum, magnesium, sodium, and we've already unveiled the fact that sulfur normally does not lose or gain electrons, right? It's pretty unusual for it to do so. It can, but it's unusual, right? So for these 3, if it's phosphorus and X is aluminum tends to lose electrons, so it'll go on to 10. And if it's whatever Y is, it can be aluminum, magnesium, or sodium, right here, right? So it can't have 18 electrons, can it? It'll be brought down to 10, because it has a smaller. The stable ion formed by it is smaller, right? Now, he's saying element with the greater atomic radius. Which of these would have a greater atomic radius? X or Y? Y or X? Shabash. Think, shabash. Okay, So the trick involved here was some of you might have thought about the negative ion. You might have thought the P3 minus ion, the phosphide ion, the sulfide ion, the chloride ion. You might have thought of this, and then you might have thought of the sodium ion and the magnesium ion and the aluminum ion. And you might have thought to yourself, hey, if aluminum is 3 plus, so magnesium is 2 plus, sodium is 1 plus, they're all pretty small compared to these negative ions, right? The negative ions are pretty larger. When you have, because of spin pair repulsion, this becomes a larger ion. So you might have thought from the perspective of these ions, and then you would have gone for, hey, Y has a greater atomic radius. But he's not talking about the ions. He's saying which element has the greater atomic radius. And you know, across the period, for elements, not for ions, I'm not talking about the ions, for elements across the period, what happens? The atomic radii decreases. So please, it's all about reading the question. He's not talking about the ions. Yes, if he said which ion has the greater atomic radius, then I'd most probably say that the ion of Y has the greater atomic radius, because when sodium ion or magnesium ion or aluminum ion loses electrons, then their positive cations are automatically smaller than their atoms, right? And anions are automatically larger than their respective atoms. So then I would have gone for B. But now I know that across the period, so X is towards the left of the period and Y is towards the right of this period. So when you go from left to right, the atomic radii decreases. And we know why. There's increase in nuclear charge, the shielding almost remains constant, the effective nuclear charge increases, and the pull on the outermost electron increases, therefore the atomic radii decreases, and therefore A is the correct option. Any question? So it's pretty basic to do these questions, pretty logical, no like rocket science involved. And inshallah, a couple of days later, we're going to start doing these questions. These are 60 questions, guys, 60 questions from just 2024 set. So that's why I've called this part 1. And we're going to do part 2, part 3, part 4, probably 4 parts. We'll finish it off, inshallah. Any questions, guys? Did you guys enjoy today's class? Did you guys enjoy? Again, I'm just repeating for Faryal. Faryan is saying, wouldn't it be B? Y forms an anion with 18 electrons, which is larger than X cation with 10 electrons. Faryal, you're absolutely right. But Y, he's not talking about the ion of Y. He's talking about the element Y. That's what I said right now. That if you were talking about the ions, then Y's ion would be larger than X's ion, right? This is the entire aspect. This is the entire idea to know he's talking about the element. And you know, in its elemental state, across the period 3 or even period 2, the atomic radii decreases. Right? There are no exceptions to it. It just goes down, down, down. And we've seen it right here. And if you want to see it, I'll show it to you right here. It has been tested in this particular MCQ. What is this? Look at this. Look at this fella. Faryal, see? Seeing this? So you are right, absolutely. But for the ions, it's just reading the question. That's important. See, atomic radii is decreasing across the period. Done?